Welcome to this explainer. You know, have you ever stopped to wonder why we are so incredibly obsessed with putting our messy, unpredictable real world into perfectly neat little boxes? Well, today, we're going to explore how humanity's drive to build perfect, formalized systems follows the exact same architectural arc across law, mathematics, and computer science. Seriously, it's like a grand, unified theory of system design, and it is absolutely fascinating to see how it connects. Let's get into it. All right, let's just dive right in by figuring out what formalization actually means. Simply put, it's the process of taking messy, unwritten, highly contextual human reality, think of something like an unspoken office culture, and codifying it into structured, explicit, rule-bound frameworks, like turning that unspoken culture into a massive official employee handbook. We are basically taking the ambiguous and trying our hardest to make it absolute. Which really brings us to this massive, fascinating question. Why do we do this? Why do we constantly try to trap reality in rigid rules? From ancient kings writing legal codes on stone tablets, all the way to the algorithms that are curating your social media feed right now, we literally just can't seem to stop ourselves. What is this psychological or societal drive behind our relentless need to map chaotic human behavior into perfectly organized, predictable boxes? So here's our roadmap for today's explainer. We're looking at 1. The drive toward formalization. 2. Gratian and legal structure. 3. Algebraizing continuous geometric space. 4. SGML and structured text. 5. Textualism and unfaithful agency. And finally, 6. The substantive backlash. We're going to cover a lot of ground really fast, from medieval monks to 1980s coders. Okay, section 1. Let's look at this fundamental drive to formalize the world around us. Now, you might be thinking, well, that just sounds like adding bureaucracy for the sake of it. But actually, the process of turning unwritten customs into explicit rules historically serves a huge purpose. It's meant to secure transparency. Think about it. If the laws aren't written down anywhere, only the people in power get to decide what they are, usually on a whim. So whether you're a medieval peasant looking at newly written laws or a modern programmer diving into open source code, formalization is a real game changer. It serves as an instrument of democratization, a mechanism for administrative control, and a vital tool for universal accessibility. Moving right along, section 2, Gratian and legal structure. Let's jump back in time to see how this drive totally transformed medieval church law. This brilliantly illustrates our first major historical leap. And honestly, it was just a chaotic mess before this. Imagine trying to settle a legal dispute, but your rulebook is made up of 500 years of totally random, contradictory letters, localized traditions, and papal decrees scattered all over Europe. That was church law prior to the 12th century. Just a nightmare. But then, around the year 1150, a jurist monk named Gratian steps in. He compiles the Decretum Gratiani, taking all of that decentralized chaos and synthesizing it into one single, coherent, logical framework. And Gratian, he didn't just staple these old documents together. He acted like an architect. He actually introduced causae, which were essentially medieval law school hypotheticals, to test legal problems in a practical way. When rules contradicted each other, he used dialectical logic to reconcile them. Plus, he established a strict hierarchy of authorities, so you knew exactly which rule trumped another. By doing this, he successfully introduced strict jurisprudence into canonical thought, formalizing a system that would go on to govern Europe for centuries. All right, section 3, algebraizing continuous geometric space. We are going to completely shift disciplines now and see how this exact same formalization arc happened in the realm of mathematics. So prior to the 17th century, math was honestly kind of stuck. For millennia, European mathematics maintained this super strict conceptual separation between discrete arithmetic, so numbers, and continuous geometry, shapes in space. You couldn't easily model abstract curves using traditional Cossack algebra. Why? Because back then, equations were strictly tied to concrete physical dimensions, like the actual physical length of a piece of wood. Enter René Descartes and Pierre de Fermat, two brilliant minds who independently shattered this whole paradigm. Both men formalized physical space into manipulable algebraic equations, but they approached it like rival architects. Descartes was incredibly strict, demanding a rigid taxonomy of curves. He wanted them classified as strictly geometric or mechanical. Fermat, on the other hand, played it a bit faster and looser. He embraced a much broader analytic treatment of higher degree curves, totally dropping those rigid constructive limits. And this leads us to what is just a massive leap forward in mathematical history, Fermat's concept of adequacy. Basically, Fermat formalized continuous geometric space into discrete algebraic steps. How? By temporarily tossing in a tiny algebraic parameter called E to set up approximate equations. He'd do his mathematical manipulations, and then, and here is the absolute magic of it, he would set E to 0. That tiny parameter just vanishes, leaving behind the exact calculation for a derivative. By translating continuous space into manipulable symbols like this, he practically handed us the keys to differential calculus. Okay, let's fast forward to the 1980s. Section 4, SGML and structured text. We are moving from math straight into the digital encoding of text. Just like Gratian did with law and Fermat did with math, a computer scientist named Charles Goldfarb tried to perfectly formalize text processing. In 1981, he laid the groundwork for SGML by establishing a very strict binary distinction. On one hand, you have descriptive markup, which identifies what a thing is, like tagging a sentence as a title. On the other hand, you have procedural markup, which tells the computer what to do, like saying, make this text bold and 24-point font. But here's the catch. Goldfarb's strict binary had a fatal flaw. As digital humanist Alan Reiner pointed out, Goldfarb was actually mixing up two totally different things. He was conflating mood, meaning whether a tag describes something or commands the computer, with domain, meaning whether it deals with the logical content or the physical formatting. Reiner built this matrix to prove his point, showing that human text is just far too complex for a simple, rigid binary system. To really see this, just take a look at the intersecting box in the top right of this matrix. Think about this. What happens when a historian simply wants to record the fact that a 19th century document was originally printed in bold text? It's indicative because it describes a historical fact, but it's also renditional because it deals with formatting. Goldfarb's original strict formalization couldn't cleanly handle this overlap at all. It proves once again that messy reality always complicates strict rules. Which brings us perfectly to Section 5, Textualism and Unfaithful Agency. Let's head back to the law to see what happens when strict literalism goes just a little too far. Looking at Justice Antonin Scalia's 1995 Tanner Lecture, we hit this massive architectural debate between strict textualism and reasonable textualism. Textualism argues that a statute means exactly what the text says, period. But strict textualism can lead to outcomes that follow the words perfectly, but are completely undeniably absurd in reality. It's essentially a debate about system design. How rigidly should we adhere to the code as written, even when the real-world output seems like a massive glitch? Now, zooming out for a completely neutral, academic look at the other side, we have the purposivists. They argue that a legislature just enacts a social artifact of printed signs, a law. It's up to judges to interpret it and turn it into the law. They actually argue that strict literalism is unfaithful agency, because treating a text as a perfectly formal, isolated object completely ignores the fact that it's a human speech act. If you totally divorce words from their historical context and their practical consequences, you really risk some absurd or even cruel real-world outcomes. And here we are at the climax of our arc. Section 6, the substantive backlash, the inevitable collision between pure formalism and reality. This is exactly how the battle lines are drawn across every single discipline we've looked at today. On one side, you've got pure formalist literalism. It adheres strictly to closed texts in law, restricted curves in math, and rigid code markup in computer science. And honestly, this establishes wonderful, super predictable baselines. But on the other side, you have this substantive functionalist backlash that inevitably steps in. It focuses on contextual human intent, adapting to complex social and economic realities, precisely when those rigid rules fail to capture our messy, real-world complexity. So, what's the big takeaway from all this? It's that extreme, systemic rigidity almost always triggers a functional backlash. Whether we're talking about Gratian's medieval decrees, Fermat's algebraic equations, or Goldfarb's digital code, our systems need a productive dialectic. We absolutely need formal rules to build a predictable baseline so that society, or a computer program, can actually function. But we have to combine them with open-ended, functional standards so we can adapt when those perfect rules inevitably collide with our very imperfect world. I'm going to leave you with this final thought to ponder. As we rush headfirst into the era of algorithmic governance, artificial intelligence, and computerized smart contracts, will our formal systems finally trap human intent perfectly? Or is messy, beautiful, totally unpredictable reality always going to demand a rewrite? Thank you so much for joining me on this explainer. Keep questioning the systems around you.